Hi, I'm Tina from Prep 101. In this video, I'm going to teach you how to find the inverse of a function. This is typically 1 mark on your first exam. Okay, let's get started. So first thing I'm going to show you is the graph of y equals e to the x and the graph of y equals ln x. So these graphs are inverses of each other, and that means they're a reflection in the line y equals x. So y equals x is 0, 0, 1, 1, 2, 2, negative 1, negative 1, etc. And you can see that if you draw the line y equals x, y equals e to the x goes through 0, 1 and kind of extends down and goes all the way up like this. And y equals ln x goes through 1, 0 and has an asymptote of the y-axis and goes up like this. So you can see that it's a reflection in that line. So if we talk about the domain and range, one thing we know that domain of the original is the range of the inverse and vice versa. The range of the inverse is the domain of the original. And so sometimes you might be asked something like that. So if we talk about the domain of e to the x, well, e to the x, you can put any x value in here. E to any x value you can work out. You can put e to the 2, e to the 3, e to the negative 2, e to the anything. So that is from negative infinity to infinity. The range of y equals e to the x, well, look at the y values for e to the x. It doesn't cross the x-axis, so it's anything above 0. So it would be from 0 to infinity. Round bracket because 0 is an asymptote, so it just gets closer and closer to 0 but doesn't touch it. And if we look at the domain of ln x, well, it's going to be the range of e to the x, so 0 to infinity. And you can look at the graph and say, oh yeah, the domain here starts at 0 and goes up towards infinity. And the range of ln x is the domain of the original, which is negative infinity to infinity. And you can see that if you look at your ln x graph, it goes up forever and down forever. And so every y value would be part of the range there. Okay, so one type of question that you can get on your exam is which of the following graphs has an inverse? And so the best thing I think is to just make a quick sketch and see. If you're looking at an inverse, you're looking at the horizontal line test. Does every horizontal line you draw only cross the graph once? Does every horizontal line you can draw only cross the graph once? If the answer is yes, it only crosses once, then yes, it has an inverse. If it crosses more than once anywhere you draw a horizontal line, then the answer is no, it does not have an inverse. So look at f of x equals 5. If we look at a quick sketch of that, it's a line, right? Y equals 5, straight across. And if we draw a horizontal line there, it touches it everywhere. So that one is no, it does not have an inverse. Y equals x squared plus 2 is your parabola y equals x squared moved upwards 2. So it looks like this, moved up 2. And there's our vertex. And now again, the question is, does every horizontal line only touch the graph once? Well, if I draw a line there, it touches the graph twice. So then this is no, it does not have an inverse. If we look at y equals root x, if we do a table of values here, we can take the root of 0, we can take the root of 1 and get 1, we can take the root of 4 and we get 2. So 0, 0, over 1 up 1, and over 4 up 2. So that's a quick sketch of y equals root x. We will look at all the different graphs you could possibly get on the exam during prep, and I'll remind you of what all of them look like so that you can practice them for your exam. But here, every single horizontal line I draw, every single one will only touch the graph once. So this is yes, this does have an inverse. And the cubic graph, well, the cubic graph, y equals x cubed, looks like this. 0, 0, 1, 1, negative 1, negative 1. So you can draw a quick sketch. And then it looks like minus 1, so that's just going to move it down 1. So that's y equals x cubed minus 1. And here, every single horizontal line I draw, no matter where I draw a horizontal line, it's only touching the graph once. So the answer is yes, this graph would have an inverse. So that's an example of a common question that you'll see on practice exams. The other one is how to find the equation of an inverse. So your steps to finding the equation of the inverse are, number 1, use the horizontal line test. to see whether it's an increasing or decreasing function, or show that it's a one-to-one function. In other words, check if every horizontal line only touches the graph once. Number 2, switch your x and y. And number 3, solve the equation for y. So generally these questions, you are just going to switch x and y and solve for y because all the answers will just be algebraic. The graph one is where you'll definitely want to test the horizontal line test. So if we do an example here, if f of x is 3x plus 2, find the inverse of y equals f of x. So I like to write it as y before I start. So that's what y equals, 3x plus 2. So switch x and y. So I draw x with an arrow to y, so switching them. So x is 3y plus 2. And then I have to solve for y. So how do I solve for y? Well, I'd bring the 2 across, so it'd be x minus 2. And that would be 3y. And then I would divide both sides by 3. So y is x minus 2 over 3, or f inverse is x minus 2 over 3. And that would be our final answer. So sometimes there's a question on the exam that just says find the equation of the inverse. Okay, so number 3 here says find the equation of the inverse of 3 over x plus 2. So hit pause and let's see if you can do it here. So we've got y equals 3 over x plus 2. So we switch x and y. So we get x equals 3 over y plus 2. And then we cross multiply. X times y plus 2 equals 3. So xy plus 2x equals 3. And we're trying to solve for y, so I would isolate the y term. Xy equals 3 minus 2x. And then divide both sides by x. So y is 3 minus 2x over x, or f inverse of x is 3 minus 2x over x. And that would be our answer. Okay, so we're going to do 2 more. So I'm going to write down the equations. And again, you can hit pause to try them and then check your answer after. So for this example, we've got find the inverse for f of x equals 2x plus 1 over x minus 1. So we're going to start with letting y equal 2x plus 1 over x minus 1. Then we're going to switch x and y. So we have x equals 2y plus 1 over y minus 1. And then we're going to cross multiply. So we have x times y minus 1 is equal to 2y plus 1. So any ideas of what you could do now here? We're trying to solve for y. So what I would do is I would distribute the x, multiply it out. So we would get xy minus x equals 2y plus 1. And now we have all different terms. We have 2 terms involving y and 2 not involving y. So I would bring all the y terms to the left. So we have xy minus 2y when we bring it across equals, the 1 is already here, and then the negative x moves across to become positive x. And then the tricky step, when in doubt, factor. So here we have a common factor of y times x minus 2 equals 1 plus x, and our final answer is to divide both sides by x minus 2. So y is 1 plus x over x minus 2, which means that's our inverse. F negative 1, or f inverse of x, is 1 plus x over x minus 2. Now we'll do one more example that's a little bit tricky. So here, number 5, find the inverse of y equals sine inverse of ln x. So first thing I'm going to do is write it down. Y equals sine negative 1 of ln x, sine inverse of ln x. And then I'm going to switch my x and y. So x equals sine inverse of ln y. And this is the tricky part. Can you think of what you could do to be able to solve this for y? So what you would do is you would sine both sides. So sine x equals sine of sine inverse of ln y. And then we have sine of sine inverse here. And so those operations cancel each other out. And we end up with sine x on the left. And when these cancel, we end up with just ln y left. And now when we cover exponential equations, we'll talk about putting a log into exponential form. And so in this case, we will put this into exponential form. Ln is log base e. So our exponential form is the little base, which is the e, to whatever's on the left side here, e to the sine x, is equal to what we've got to take the ln of here, which is y. And so that's called exponential form. So we'll practice that in another primer video when we talk about exponential functions and graphs. So our answer here is the inverse, f inverse of x is just e to the sine x. I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.